Okay, it looks like we are live, so welcome back. Today I'm going to be continuing to work on Canaan. Okay, so, yeah, last time, ended a bit abruptly, and was not able to finish on stream when I got done. But I did actually, it's being kind of weird, but okay. I did get it working, at least what we were working on, right? So now you can do, let's see, I don't remember how it was. It was, set wrong, right? And then indent to, an expression. So 4 plus 4. You can only use plus right now. 4 plus 4. Shoot, did I? I swear it was working. What the heck? That works. That works. Hang on. What the heck? Wait, now it's working. Why is that seg fault? Huh. Okay, that is obviously a problem. I did not know how to hack. So let's see. So I suppose we could use some logs to see where that's happening. So this is the old stuff, I think. Yeah, so we have interpret command, and that is where we need to do stuff. So that's printing the tree. That was just for debug purposes. So here's where it's happening, right? So this is where it's getting evaluated. Let's see if we even get to this point. Else, right? Hang on, let me see. Yes, we interpret it. Right log here. Let's see if we get to this point. First we have to build it. I did not know it was that. I didn't test it right before the stream, but the other day I was testing it and I thought it worked. Let me log. Alright, set log. And 4 plus 4. Now it works. What the heck? What? 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 What the heck? Wait, what? Oh, I must have. Here, hang on. Okay, I must have pressed tab or something there. Okay, yeah. You saw that, right? It was, okay. I don't know, I must not have rebuilt it properly or something. I have no idea. I don't know. Maybe we will encounter that again, but that's kind of strange. Okay. Anyway, so yeah, I have this function now, interpret expression. So you pass the start of you pass the node that has the expression, and then it will interpret it, right? Yeah, it's just like recursively, where it adds it. Right now, it just adds. I'm gonna not worry about any other operations yet. Just like add. Yeah, and I want to get it working for all of them. So we have set var, that's working. But I would like it to work also with the other ones where we use numbers, right? So let's see. I think some of these can be re-implemented, like just how they work. So set output. Yeah, so this can be exactly the same, right? More or less. I might need to change some variable names and stuff, but it's pretty much the same. So let's see. Set output right here. Okay, that indentation did not quite work. Okay, so if command size. Alright, let's see. So do we have command size here? We do not. Yeah, because we have nodes now. So we need. Well, we don't actually parse this now. Actually. Do we still parse it? No, I think we need to. Yeah, we need to implement the parsing. But basically, so we don't have command size. Yeah, so we don't have to worry about that in here. Just want to set the file name equal to let's see, is it gonna be it'll be the right value, right? Like the node right. So let's do node right value dot as stir. I think that's what we have, right? As stir. Yeah. Stir literal. So that's a stir literal. Hang on. So what is that? Yeah, dot value. So we just have to do dot value. So let's search for that. Shoot, what? Shoot. Messed stuff up. Hang on. That is started. Let's go there. And then dot. There we go. And that should work. Once we parse it properly. Alright, so let's see. Excuse me. So set output. We're gonna have tokens here. So first of all, we need to check the command size, right? So the command size should just be 2. So if command size equal 2, is that right? So we have set output, yeah, it's unequal to, then return null. So I don't actually check that right now, but that's okay. And then if not expect token, right? So the second token, well, the first token, well, the second token, but it's the first index. It should be TT stir literal, right? And that's all that we have in this case. So if it's not that, then we will return null. Okay, so we have the errors out of the way. So now let's see, we can make node val, sort of copying what I have up here. So we need to actually create the node, right? Equals create node. Node keyword. Now, so we have to pass the value in there. And so the val dot as keyword equals command 1 command 0 dot type. So this is actually all the same things. And we always are going to have a keyword as the root. So I think we can move this out, right? And do it before the switch state. Since it's going to be the same all the time. And I don't. Okay, I didn't copy it. But I can copy it from here, so it's all good. Let's do this. There we go. Okay. So then you have the root. So we could even define it here. We can get rid of that. There we go. Yeah, because that should create that. So that should be fine. We should probably check though that the command size is greater than 0. Command size. Let's see, less than or equal to 0. And just return no. And that should be fine. Okay. Excuse me. So then we can get rid of this. Because it's gonna be the same each time. So we are all good in terms of that. So we have the root here. Then we can just create the right? So root right equals create node. And so we're gonna have to set that. So it's gonna be a node node stir val. So the val dot stir equals command 1 dot val. I think that's pretty much all we have to do for that. So we don't need the left node, so I can just stay null. Because there's no use for it, right? So we have some issues. TT stir. Right, so that doesn't exist. So what is it? We have that. TT string. Okay, so I guess it's just string. Sure. String. Oops. String. There we go. Let's see. What other issues do we have? Stir little. Okay, yeah. So we need to cast that. Let's do something like that. I really should just make it a string, but whatever. So it is stir. Okay, and it doesn't like that either. Okay, maybe I'll have to define that. Sorry. Stir rate equals and 1 dot value. Then we can just put that here. Well, I have to this. I have to actually give it a name, and then we're gonna this. Okay. There we go. Now let's see. Thinking more problems. Stirlet design this. What is it? Wait, what? Hang on. Oh, it's stir literal. Okay, that might have actually been the problem. Whatever. Okay, node. We don't have node. It's a root. No, hang on. Where am I using that? Hang on. 354. Alright, so that's something down here. Okay, yeah. So it is. We don't have node. Okay, so we need to be root. Excuse me. Alright, so it compiles. Let's go set output to .txt. Okay, and then when we type stuff and save it, and okay, so it's not quite right. Okay, because why is it like that? Okay. I think we need to like strip it first. No, why would I do that? So get the quotes. Oh, okay. Oh, shoot. So it's not supposed to be a stir. Yeah, so I think, yeah. So it's not supposed to be a string, actually. It's supposed to be, just like, okay, I don't know what I call it, but, well, so I'm gonna change it so that it is a string, because, I'd rather have it be that. Not set bar, but set output. And we don't actually report errors right now, so it's not gonna save that. And it's not gonna save, yeah. So it doesn't set it, because it's expecting a string. But that's not what it's supposed to be. So what was it previously? Do I still have any of that? Okay, well, we want it to be a string. So that is, so we have like the parsing and stuff in place, but we need to strip it. So how do I do that again? I had some function for that. Okay, view chop left. Yeah, view string internals. That's what I want. So like, because it has the quotes on it, that just basically strips the quotes off. Excuse me. Okay, so we can do. This is the wrong place. Set output. There we go, right here. Yeah, so we want it to be view string internals of this. Okay, let's see. Does that compile? It does, and that should fix it. So set bar, no, set output to text.txt, and you put quotes around it, and then save that. And it did not work. Why did that not work? It still has the quotes. Did I not save it properly? All right, let me save it a few times. There we go. Sometimes it doesn't save. I don't know why. Looking into it though. Save it. There we go. Now it actually did. So that is what I want. So yeah, strings around it. I think that is perfectly fine. So okay, so that's good then. Okay, so we have set output. So set map, that was the key map. So I'm not gonna do that yet. I'm gonna try to do let, right? So this is gonna be let variable name. And then yeah, so it's sort of gonna work how it worked before. Let's grab that, but we're gonna parse it instead. So here's let. I'll just copy this whole thing, and we're gonna treat it a bit differently, right? Do that. Okay, do that. So the indentation is a bit off. That's okay. Oh, actually, that's right. Okay, throw that there, and there we go. So we have this. But we need to actually create the tree out of it. Excuse me. So, var. So create the variable. Name. So we still want to get the variable name. And we're going to create. Let's see. What is it called? So we have a variable, right? Identifier. So where is that defined? Okay, yeah. So we're gonna create an identifier. So we're gonna do where did I put it? Val. Yeah. So val as ident equals var. So we need the name and then the value of it. So shoot. Actually, is that gonna work? Because we need the value, but the value could be an expression. So for now, I'll just set it to yeah, I'll just set it to that variable var. So instead, this is going to be an identifier, and we set the name to that, and then var.value equals command2.value, and we need to do view to int, but convert it to an integer, and that'll be right. So we won't worry about the expressions just yet, and then we don't need any of this, but we just have to set, yeah, we need to set no, root right equals create node ident and val. That's that in there. Okay, let's see. Let's see if this can compile. So some issues. Yeah, we need to just return null here instead of these. Yeah, and I'll get to proper error handling later. Returning int from a function of type node. Okay, yeah, so I have another one. Yep. Okay, I just did not see that. My bad. No. Okay. So mu to. Alright, so the name needs to be just like that. That's fine. We'll actually convert it to a string later. Okay, so that compiles. So we can parse it then. I'm assuming it works actually. So we just set the right. So actually we need the name. So the name is going to be the left. Okay. Actually, I don't quite want it like that, do I? Yeah. So we want the identifier to just have a. We don't need a value for it. Yeah. Equals that. So we don't need the value at all. We just need the name. So it could even just be a string view, right? But whatever. Okay. Yeah, because the value is actually set. So that'll be the root right number, right? So root right equals. It's gonna be the expression. So we can parse all that because we can do it the same as this. So that's the left. So it's basically just the same thing that we have here. Okay, so we can just copy that even and do this. Paste it in there. And let's see. So yeah, we set the right number. And that should work, I think. Okay, so that works. So we should be able to parse that then. Excuse me. So yeah, I'm gonna actually update this because we don't need the value in there because that doesn't make sense to store it. We just store the name. But for now, I'll leave it as that. So now we can actually interpret that. So let's go pt right. Actually, that's not what we want. It's not that. I guess it is that. Why is that? Okay, whatever. So that's the type. Shoot, this is the parsing. Yeah, I need to interpret. I need to see interpret right here. There we go. This is what I want. So yeah, node let is what we're looking for. Shoot. Okay, yeah. TT let. Okay, I see. I forgot how it was structured. Alright. Excuse me. So we need something like this, but we're going to create a variable with a name and value, and we're going to actually do something. So it's going to be very similar to this, but we're not going to use a config bar. So let's copy that, and let's see. So node. I'm going to need braces around it. Let's see. Alright, so yeah, this should be pretty much the same. This is just this is interpreting the expression, right? So we set the value, but instead of this, we want to create a variable, which is going to be a variable, right? So that was a bit of a weird sentence, but okay. Value as ident. So it's going to be that'll be the dot name. What name is that? Equals. There we go. So we set the name equal to the left value. We need dot name. Okay. So yeah, a lot of dot names. Okay. And then root right type equals expression. We need that. Otherwise, we just set the value like this. So we need. This doesn't need to be a pointer. So we can set var dot value. I don't know if it's called value, but it might be. I don't remember that. But yeah, so we should be able to do that. And let's see what warnings we have or errors. Okay. Try start using. So yeah, we need to actually convert this to a to cster like that. Okay. Okay. Variable. Okay, it needs to be dot value. Okay. Type int. Var value. So what is its var value? Let me see. You know, I don't remember exactly. So, I think it's in here. Yeah. Okay. So we need to do as int. That is what we need. As int. And then we have to actually append this to the list of variables, right? Okay. Alright, set not use. Yeah, so then we're going to use da append. So I have actually, we're going to look at the old way that we're doing it. And this is just the easiest way to get there. So, This is the wrong file, actually. So I need the commands.c, and it's basically at the bottom. So tt-let. So we need to da append. Yeah, so we need to actually consider float. Okay. Yeah, but we don't need to worry about that yet. So da append state variables bar. Okay, so that should append that. And we can't actually really test that it works right now. But we should be able to let x for s4. Okay, so we did that. Let's actually try to write log, right? Write log of is that. So let's do var.value.as and let's see what it is. Set var. Not set var, it's let. Set var is for common variables. Let x 12 plus 4. Let's whatever, right? Okay. I don't see any of that, so that's not good. Huh. Okay, so it seems like we didn't even make it here. Or it didn't go properly. Let x 12 plus 12. Okay. Let x 12. Okay, so it works when we... Okay, so it seems to have broken somewhere. Let me do something. So where we call this? It's right here. Let's do, let's actually look at the tree. So it prints the tree there, but it's null. So let's say if root equals null, let's just return, it's like invalid args, so we can see if it's null, you know, before we try to do stuff. Sorry, that is pretty important to check. Needs to be equal. Did not mean to do that. Okay. So let's let x 12. X 12 plus 12. Alright, so it is null in that case, so we're failing somewhere. In parse command. So let's see what I did wrong. Parse command, right? So dd let. Create an identifier and set the value. Okay. Okay. Yeah. It's because of how I'm expecting the tokens. Like, so we need to do it differently. Here, we expect that. Hang on, that should be fine next. Where else would it be returning? No. Let's just like on here 3, right? And I'll put here 2, so I can see which one's failing. Probably a better way to do that, but whatever. Whoops. What just happened? What actually happened? Huh? Yeah, I broke something. And undo does not work. This is completely wrong. What? Where did this come from? Did I jump? I don't know what happened. What? Wait, what? This is from down here. What? Oh, okay, I see. So we did jump downward. Wait. No. Okay, I think I caused some problems. Let me open it back up. Yeah, I don't know what happened. I, like, deleted half the file. Shoot, but it's still going. Wait, what? Where's command? Alright, a lot of stuff seems to have broke. Huh? It just deleted stuff. And it's gone. That's not good. And I did not commit anything, so it's... Shoot. Alright, when are we gonna try to go? Yeah, okay. I guess I need to revert and then redo everything I just did. What the heck? How did that happen? What happened? I mean, set output's still right. Let me just copy it. I have no idea what happened though. Literally, legitimately. What? Tree. And this is the interpret command. Okay, so we need that interpret expression. Parse command. Okay, so we have parse command. I don't know what happened. Let me just insert. Okay, and it actually broke. Yeah, I haven't actually tried copy pasting this much stuff, and it's frozen now. Okay, it's not like actually supported, so I'm just gonna let's see, it's like say hard. I don't remember how it works. Hang on. Don't remember how it works. Yeah. So I'm just gonna have to redo the stuff. Okay. And, whoops. There we go. Okay. Yeah. I don't know what happened at all. That's what happens when you use your own text editor, I suppose. What is this? Oh shoot! I created a bunch of stuff. Yeah. Okay. Let's start over. So what did we do? So we got the set output. We got that working. Let's first of all, if it equals null, just for now it's just program from our audience. Need a better thing for that later. Okay. Print tree, we saw that. Yeah, lost a lot of progress. So I need to actually properly commit properly. Let's get set output working, right? The way it was before. So let's go up to set output. And we need this actually down here. So we just need these things. No, we don't really need that. What we need to do is set output. So we need to create a what I did. So we need a node. Say the root node. We need to set root right equals. Well, first of all, we need to check if size. Is this the right place? No, this is interpret command, so that's not right. Okay. Yeah. I need to really revise the undo because it's not working at all, and I think that's where the issue was. I don't know what I was undoing there. This we need to set state file name equals right. Let's see, root right. Dot ends stir dot out. Something like that. Okay. We need to actually create in here. So let's check if main size is equal to and return null. Otherwise, we can create the node. Root right equals create node. Node stir val. So we need a val. Let's do val dot as stir equals the let's see. Well, so it's gonna be a stir literal. And then dot value equals and 1 dot value. Into new internals to get rid of the stuff. Alright, let's see. So that should compile. Root right is the pointer. Okay. Let's go to the first one. Alright, I spelled internals wrong. Internals. There we go. Okay, and then we have state has no memory file name. Why? Root right is a pointer. Stir. Okay. Hello, how you doing? User. Yes. Okay. No member named as stir. Alright, how do I get it again? I don't remember. Alright, so state has its buffer. Root right. Let's see. How do I get that? value. There we go, that's fine. Okay, so that compiles thing, and hopefully it works. Set output. Set fault. Okay. Huh. Assuming it's in the parsing, right? Is this wrong? View. View R. Let's put the val.answer dot. Okay, let's try to print it up. Set output. Okay. Logs. There's no logs. Oh, we need to make no logs. Because I cleared everything. Set output text.txt. Let's see. Logs. Maybe not one. We got text.txt, so that worked. That worked properly. We're right. Is this? Huh. Alright, let's see. What else do I do here? In the set output. Right. Do I have to... Did I not do that? I did do that. So, why does this... This seems to fail. Right value. Test. I can see if it's from here. So test. It's 2. I'm not going to fix the indentation because it doesn't matter. Okay, let's see. Set output. Text. And logs. So we don't get here at all. Huh. In the wrong place. No, interpret command. Huh. I don't understand quite what is that. There should be 2 items. There's not any. What is what? Oh. So don't get there. Print tree fail. Huh. Alright, so it's not returning your valid arc, so how do you print stuff? We print it to logs, like so a log file. It's just like a text file, right? And that is how we output things. Okay. Tree. So it's failing here, but it's not saying it is. Let's go back to the parts command. Right here. On text. So is it getting to that point? No, that's not right. Set output text.txt. So we don't get to that point. So this is failing. With right. Can't create that, but we get here. Oh, that's stop. As like a marker, right? Let's see. Set output. Text.txt. Logs. Oh, yeah, so this is failing. Why is that failing? Oh, shoot, I know why. We don't have root. Okay. I forgot that, yeah, so I need to leave this stuff out. So now, I've got NS keyword. Equals command 0. Type, and then create the root node. I forgot that I moved that. But then I had to move it back, because we reset stuff. Anyway. Okay, now it should actually work. Set output. So it was null, that's why it was failing. We're trying to create that. So text.txt, and we had text.txt. So make sure it actually works. Set output text.txt, and save that. And text.txt, and there we go. We got that. Perfect. Okay. I'm gonna commit this then. I don't have to do it again. Let's see. So set output. Parsing. Alright, push that. It wasn't very much. Okay, so we have that. So let's try to do let again. again. Yes. So it's going to be like this. Rather similar. Okay, let's see. So what's going to be different? This is going to be the same. This parsing of expressions here. This should not be config identifier, but it should be ident, right? We don't need this config bar stuff. So left equals create that. So we're gonna put the identifier in this. This is gonna be main ident, and then val. So val as ident equals let's see. We're gonna create a new identifier, and the dot name equals man1 dot value. And I think that should work. Okay, and left equals left, so we can just set it directly. Root left. There we go. And then yes, we do this for root right, so that should be fine. Whoops. Okay, so that compiled. So hopefully that works. I'm going to make sure it doesn't. Let's do let x 12 plus 12. Okay, so we don't get any errors or anything. So we don't have a way to. We don't actually interpret it. So we need to do that actually. So tt let. So that's going to be similar to what we have here. But not exactly. So I'm not going to worry about the integers or the floats right now. We need to create a variable, and we need to do similar to what's here. So tt let, let's go back up there, tt let. So, let's see. Better way of indenting it. Okay, so we need, yeah. Again, I'm not gonna do all this stuff. Okay, get rid of that. Okay, so variables, create a variable. And we don't want command 1 round value, but we want the node, what's actually root let as stir, dot, root let value dot as stir dot. Okay, not as stir, but as ident dot name. So that will be the name of it. The type, yeah, so type is int for now. We set the value to the root right. We need to actually parse the expression. So let's actually grab that from up here, because we do that up here, like this. It's going to be the same as that. Alright, so, node equals root right. Yeah, so we'll set var dot value dot adds in actually. Okay. Excuse me. And then we have paint. Alright, so that should work. Okay. We need to actually add braces here. Set up your awesome window manager. And you got everything working properly. Brightness and the volume work now. Nice, nice. And so you fixed that problem that you were having with what was it, screen tearing or whatever, by using a compositor, you said, right? Yeah. Okay. Did not crash or anything. So let's try to output the value. Now is that r.value as it. Now let's see what it is. Let x 12 plus 12. Value is 24. Okay, and that is 12 plus 12. So that seemed to have worked. So I'm assuming that works. So let's try to implement echo now. Today's watching. I was watching CS, and I think I've got the art of posting pastas in the chat. Like the copy pasta things, like all the ASCII art or whatever. The echo, so we need to implement that. So that should not be too hard. So we don't need all this stuff. What is this? Yeah, so this is, yeah, if it's a string or otherwise. Let's actually grab all of that. Okay. So funny when the pasta is good. Yes, you have a good one in post. Okay. In the echo, let's do that. Let's see. Index it properly. Okay, so we do that. We don't want this. So we want the node. Let's see. So how does it work? So we echo, yeah, so node left. It'll be, or node, it'll be right, because right is typically the value, right? Node right. So how do we check that? I don't remember exactly the syntax that we have, so maybe we should parse it first. So let's do that. Let's do the parsing. So echo, right? So we're going to, if command size is greater than 2, then return, we obviously want that. Hi streamer name, it's me, your only viewer. Over the years I've been creating the illusion that a lot of people are watching your streams, but it was me. Now, nice. That makes sense. It's not that it doesn't make sense, right? That is pretty fun. It'd be even funnier though if you posted that and then no one else also posted. Okay. That would be quite fun. Okay, yeah, then we need to expect token. Command one. So we want it to be either an ident or yeah, I get it. So it could be that, an identifier or a string. So it's neither of those. That's the modern humor. Yes, the best kind of humor, right? Okay. So we need to set the val as okay, so we created the root node, and that is the echo. So as not ident, but as string. Well, so it depends on what it is, right? So it's either gonna be a string, or it's gonna be an identifier. So I need to think about that. I'm gonna do that. I'm gonna take a quick break, like about 3 minutes, and I will be right back. Okay, I am back. Putting parties copy and pasting, yes. Disrespectful towards the mods. Yeah. What you need to do is actually plan it beforehand and get the mods in on it. That'd be funny if you had the mods participating as well. Okay. Then it's not as disrespectful, right? So we need that, right? So it could be a string. It's important not to overdo it. Yeah. Stir literal. Okay. I cannot spell. Well, a joke repeated 100 times isn't funny. I don't know. Sometimes it is though. Like it gets funnier the more you say it. That's kind of rare though. And one value. So that is if in1.type equals TTI. Okay. So if it is that, then you take that. Otherwise it is I get that wrong. If it's a string, you want to do that. Otherwise, we want to set it to the you need to yeah, we want to handle getting the value from the variables when we actually interpret it. So we want to just set the value as ident equals identifier, and we need to do dot name equals command1 dot right. So that's pretty much it, right? But we need to create root right equals create node. It's actually going to be two different ones. So it's either a node ident or a node string. Right. From that. Let's whoops. Now I discovered that and did not copy it. So node ident now, or right equals create node stir, I think. Right, let's see if that compiles. Okay, it does not compile at all, so cause is not guard. What does that mean? Oh shoot. Okay. That is a problem. I hit that before root. Okay, yeah, I forgot that semicolon. Okay. This is supposed to be an underscore. Okay, it's a root, right? Where do I use now? What? Oh shoot, that is in the interpret. So this all is working. So it's just interpret command that is not. Yeah, because it's not set up properly. So it's a funny program story I've heard. A test was made that told you how smart you were, and the catch was that it didn't matter what answers you had, because the test told you were very smart. But when the results were shared on Facebook or something like that, everyone saw that you were actually dumb. Because you believed it? Hang on. I might be actually dumb. Let me try to read that again. Okay. I don't Cookie said whether you passed the test. Not quite sure I understand. So everyone else saw that you didn't actually? I'm confused. I'm a little confused. I'm one of the dumb ones. You knew you had, it showed good results, but when it didn't, it showed, oh, okay, I see. Okay, I see. Yes. Alright. Hang on. So node right is what? Node right type. Yeah. Type equals, not teacher string, but node stir. Then we'll need this stuff. Otherwise, we'll do other stuff, and we will, yeah, so we need, let's see, state variables. Yeah, so we get the variable, and we compare it to this, but instead we want node right. Right. Value. Dot as item. Dot name. Right, so compare that, and then that is it for that part. We don't need this return no error though. We do want to return just that. Yeah, because we don't want to do anything else again. And then that, we don't want that. That says I want to share with your friends how smart you are, but they don't have the cookie that's stored in the browsers. Okay, I see. Yeah. That is pretty fun. One of the best troll acts you've seen. What was it called? So that should be fine. But then here we need to actually get the int right, not node, but root. Yeah, I need to be root. Right. Okay. Right. Value. That's third. Not value. Okay. And do that. Let's see. So let me build this. Okay, so it does compile. Like the echo s. S. Okay, that's not right. I'm messing up here. Echo s. Echo s. S. Echo. Alright, so we don't get the entire string. Okay, that is not good. Why is that? Alright, would it be in here? Let me, log. View. Okay. VR. Start. And let's see what it is. So, you know what? I think we're stripping it off twice, aren't we? Actually, yeah, I think that's exactly what it is. So, let me just get rid of this. Because we handle that at the parsing state. I'm pretty sure that's what the entire issue is. So let's it's just stripping off the quotes and then trying to do it again. Let's say but echo text. There we go. Alright, so now that works. Let's try let x 12 plus 12. And echo x 24. Okay. That worked okay. So let y let's see 54 plus 10 plus 12. Echo y. 76. Okay, I'm assuming that's right. I didn't actually. Alright, but that seems to work. So yeah. Now we can use those. Let me commit this. I cannot type. Okay, so implement echo and let parse it. Push that. Okay, that is pretty good. That is pretty good. So what are yeah, so a lot of these we don't need, like they're unreachable. Let's see, we should probably implement save. We don't have save. Shoot, so we can't actually save. That is interesting. Why is that not the first thing I implemented? Okay, so save, we don't really need to do much, we just need to create the root node, and that's it. Let's go to the parse command. Yeah, so, let's see, if it is save, then we can just break. And the same thing with exit, and save exit. So yeah, all these just can fall through. Because it's really just, the root node that we need for those. Okay, and then we can interpret it here. So let's see, node keyword, and if it is save exit or save exit, then we want to do this stuff basically. Basically the exact same thing as these. Okay, seems to have not worked properly. Let's see, handle save. I'll just type it out. That's fine. That'll probably be faster. Handle save buffer. Whoops. Buffer. There we go. Equals 1. Handle save buffer and quit it. Okay. And that should work then. It's gonna save it. Yes. Okay, so now we should be able to save and stuff like that, which is pretty important. Like before you could do it with Control S or whatever, but not with the commands. Let's type stuff, and then let's write exit. Okay, and then see, and that that is right. So that's pretty good. Yeah, that is important to have. So pretty sure all of these are just like unreachable. So I can think something like that. Search 0 and unreachable. I'm pretty sure they are. They should be. I'll figure it out, obviously. But probably the same with these. Okay, so set map. So that is mapping keys, and I'm pretty sure that is the last one that we need to implement for that at least. Let's see. So we have set output. We have echo. We have the right and stuff. We have set bar. So we need set map, and then this one is already handled differently, so we don't have to worry about that. We do have to worry about this, the set map. So we need to parse it and then interpret it. So let's see. So how do we handle it here? Let's just copy this. We can probably use most of that. Let's see. Okay, so set map. So this is the interpreting. Let's go to the parsing. All right, it's actually down here. Let's see. Set map. There we go. Okay, let's see. So we don't want to actually append anything right now. So we have a few things. So we have the first one is ident, and the second one is a string. So we need to create we know let is the ident, right? So actually root let equals create node ident from, let's see, from val. So we could actually do val as ident equals and1 dot value. And we need to actually cast that identifier name equals that, and there we go. So val, and then root right equals create node. So this will be a node stir from val. So let's do val as stir equals and 2 dot value, and we need to actually internals of that. So that strips off the the quotation marks, right? And that's pretty much it, I think. So root left and root right. Put that, and we have some issues. So yeah, these need to be returned null instead. Null. Null. No. Okay. Stir. Yes, that needs to be casting. Stir. Yes, like that. There we go. That should compile it. Okay, so that should be it for the parsing. Then we need to actually set it. So we just create the map out of that, and that is in the interpret phase. So let's copy this again. The set map. So we need this part mostly. In a bit of a break from programming right now. Is there any particular reason, or just because? Jumping between projects and achieving nothing. One sec. Need to distract from it for a while. Well, then you'll achieve less, right? Has been frustrating you. Well, what projects have you tried working on? Okay, you don't want to like that, exactly. A lot of it. Well, maybe you should pick one and try to, like, build that out a lot. You know what I'm saying? Like one bigger one. Okay, string. So we need root right. That is that. And we don't need this, really. We can just assign it to right star like that. Priorities are mostly useless and don't inspire you. And you can't find one that is not useless, that does inspire you. We'll stir. So we need, we need to that and stir. There we go, like that. Okay. Chess engine is what you've been making. Yeah, I remember that. And that's been uninspiring to you. So this is, yes, we need to get that. So we need value as item name 0. Name.data because it is a string. Okay. Close down, we've been finished. And this needs to be that. There we go. You have that and inspires you. Set map T 2D. Okay, that's it. Okay, there we go. So we have set maps. Let me get that. It does inspire. So, set map. Push. You want something new. Okay. That it is pure backend, yeah. That's most of what I needed, right? Can't work on anything with the UI. Yeah, I get that. Yeah, not the biggest fan of that. Okay, so that's pretty much everything re-implemented, right? We don't need any parsing like that for any of those, I don't think. So we should be good. Let me use these then as well. Let me just get rid of that. Yeah, because the default case would handle it. So that should be fine. So I really could just get rid of these as well. And then we're good. Okay. And so node expert, pretty much we're always going to be encountering a keyword, at least right now. F's during your painting classes at school. Dang. So you're not very good with art stuff. Okay, that should be fine. Yeah, just interpret. We don't actually ever usually get to this point. But yeah, okay. I see. So I can get rid of this now. So I do need to work on the error messages, because now they don't really work. But that should be good then. It should work. Get rid of the void there. Set var MP4.4. That is good. That works. Can you express your thoughts through UI? Yeah. I see. I understand. X 15 plus 15 X. Okay. Sounds pretty cool. Thought of hiding the cursor when typing. Not really. Like, I would like a different type of cursor. Like, here I can show in Vim, right? It doesn't hide the cursor, but it makes it like that. But I've not figured out how to do that yet. But that is, I would like something like that. Instead of not hiding it, but making it a different type of cursor. But yeah, I didn't figure out how that works exactly. That's why I'm not done yet. Okay. No. Oh, the mouse cursor? Oh. Okay, well when I hear cursor I think that. Why though? I don't know how that would work, and also, like, I don't know that I would care for that much, because I kinda like to see it. I don't know if you can hide the mouse cursor anyway. At least like easily. Sometimes it goes over the code. Well, I can just move it out of the way. Then it's not over the code. I mean, I see what you're saying, but yeah, I don't know that I would like that feature. But you could implement it for yourself if you wanted to. Okay. don't need this test here. But I have the other write lots that I don't need. Alright, so I need those. Alright, so that's all. That's good. Okay. Now I suppose I could try to get it working with more than just addition, right? Because right now it only works with addition. You can't do like 5 minus 5, but that could get kind of annoying. Having to deal with like negative numbers and randomized 0 and stuff. So I don't know that I want to do that right now. I'm gonna look at it. So I got implemented all of this stuff. So that's like up to date, right? What else? Let's see, this can be same thing. I can just get rid of those because I don't know that I need them at all, really. Because we shouldn't encounter it as the first one. But I'll just leave it for now. Like this. Get rid of that. Just so it's a bit cleaner looking, right? Okay, so set volume. Okay, so I kind of want to move those down here. Okay, there we go. Make sure that actually still files I need to something out. Okay, all good. Okay, yeah, maybe I'll look into that. So, when we're parsing it, it's gonna be in parse expression, right? Actually, it's gonna be a few things, right? So if we do this, well, yeah, okay, it's just in parse expression. So we need to check pt plus. So let's do instead of that, we just want to do check if not is operator, right? Operator if it's not. For the okay, yeah, and we just strip it off basically. So actually, so we just need to make that function, right? Is operator, and this is going to take command token. Okay, and I think that's what it is, right? Token. Yeah, it is. Just a single one. It doesn't need to be a pointer. Okay, and then switch over token not type. So, case. What are the different token types that we have? Plus, minus, multiply, and divide. So we need all those. Okay. So, case. A multi-factor would be nice to have. So that, if it's any of these, let's see, yeah, we can just do like false. We return true. Return 1. Otherwise, return false. Let's just do people X. Return false. Return 0. Okay, like that. There we go. Okay. So, where is that? Not this operator. Okay, and then we need to actually do different stuff based on the operator. So, well, do we actually have to handle anything in here? Well, we need to, let's see. What does expert contain? Let's see. Yeah, right here. So we have just the value. But binary expression has the operator. So that's what we need to do that. So binary expression. Let's see. Okay. So parsing. So we need to set the operator based on that. So we could have another one of these, which is like a similar thing, but it returns an operator, right? So it's going to be similar to this, basically. So I could probably just repurpose this anyway. So return, what are all the operator types? Yeah, OP plus, OP minus. Okay, that makes sense. plus minus turn op mult and turn op. Okay. Otherwise, just return p none. So I should probably make that. Well, yeah. So let's make op none 0 like that. You can use that. Okay, and then this, you could use that instead. So we don't need both of these. We need get operator. Let's see, get operator equals would be known, and yeah. So that's basically functions the same. So we can just get rid of this entire. Okay, and then we need to actually set the expr operator equals get operator. So yeah. Okay. Yeah, so that should be fine. Get operator command 1. So let's actually let's do this here. Like that. Get that, and then just check if the operator equals that. Okay, let's see if this compiles. These types are not handled. There we go. Alright, so now it does compile. Okay. So I should set the operator. We should be fine then. So then when we actually interpret it, we need to do different stuff based on that. So interpret expression. So excuse me. So we need to switch on expr operator. So case would be plus break case op minus case op mult break breakout break case opd break default 0 shovel. There we go. Okay. So we need to do different stuff. So this will be this case. Let's see. Expr r value dot value. Okay. Otherwise, we need to subtract. So I'm not going to worry about multiplying or dividing by 0 or anything like that right now. Let's be minus equals and alright, so I don't know if that's gonna work out. The division might cause some problem, so let's try that. Okay. So I think we need to do basically the same thing here, but let me see how that works. Okay. I forgot semicolon a couple times somehow. There we go. Right, panel. Let x 12 minus 5. 7. Okay, that worked. Right, y as 15 times 10. 150. Okay. So there's no like precedence or anything like that, but that's fine. 2. So 12 times 10. So that'd be 120 minus 20. Echo 2. So that's 2 is not right. That is not right at all. And I think it's because of this, right? The plus equal. So I think I need to switch on this again. Yeah. Okay, that actually makes sense. That I need to do this. So this needs to be interpret expr right. Basically just that same thing, right? I don't know why there's much extra space, but you know. That's cool. Okay. Let's get rid of that. Okay, and let's let x 12 times 10 minus 20 equal x. Negative 120, that's not right. Huh? How would that happen exactly? Okay. Y. F1. Alright, so we can't actually, we can't use, like, variables in other variables right now. So I can't do anything like that. But let's see. Do 50 plus 50 minus 20. 80. Does that work? Didn't work with multiplication, though. Let's see. 5 times 5 times 5. 0. That is interesting. Why that would happen. Let's maybe output the value. Value. And just sort of see what it is as we go along, you know? Let x. Let's do 5 times 5 minus 5. Let's try that again. It might be doing it in a weird order. Is it doing this first? And then doing this? That could be it, because then it would be 0. Let's look at this. Value is 5 and then 5 again. Why is it always 5? So why would it be that one first? I don't quite get that. Maybe we should print the tree. Well, we do actually print it here. Not very well though. I should print indentation based on how far down it is, right? And then there. So let's do 4 something 0 y something like that. Let's just print we'll write log space. And then when I call print tree, I need to actually pass the start 0. And then yeah, we keep calling it. We do plus 1 plus 1. Okay, let's see. Then it might be easier to read. Okay. Yeah, let's make it a size type. Size T, there we go. Let x, 12, plus 5, minus 10. Let's look at it. 12, 12, 5. See, no delay. No delay. So it did not work. Okay, I guess we didn't have enough depth. Yeah, we don't print the values or anything anyway, so that's not even very helpful. So, yeah, actually, also prints a new line, so that's not good. Yeah, and we don't have a way to print it without any line, so. Okay. Alright, I'll come back to that. Yeah, but I don't think that's gonna be helpful anyway. So, 12, 12, and then 5. I didn't even actually look at what that did, so let's do let x 12 times 12 plus 5 minus 10. 84. Is that right? Probably not. No, that's not right. Yeah. Doesn't quite work. Alright, let's see if we could print it out maybe a bit better. So I'll put the values. Let's also print what is that? What is that? Let's do value and then x for actually that's already the left value. So we need r value, which might not exist. Like it might be 9. Let's see how that works. X 12 times 12 plus 5. Right is 0, right is 5. Well, plus 5. What did that output? 204. That, why is it so much? Should bring the value before and after maybe, instead of doing this. Value. And then let's put the value here as well. After. So it'll print a few times because it's the first point in there. x 12 times 12 plus 5. So, 12 and 12, value after 17. So that's, yeah, so there's 12 times 5. Okay, and then, yeah, 12 times 17, that must be 204. Yeah, okay, so it's not, that's interesting. It's not quite right. Okay, so let me think about why this happened. So we have 12 times 12 plus 5. So it's doing the 12 plus 5, and then it's doing 12 times 12. So that's why we get that. So let me think about how the tree would look. So basically we have this, and we have more there. So what are the values of these? So the main one, let's see, we have this, and we have the left. So that is 12. 12. And then this one is another one, which breaks off, which has 2 values on it. So this one is 12, and this one is 5. So we're interpreting this first. We're doing 12 plus 5, because right, hang on. Yeah, okay, I see. So we set the value, right? So we go down here, and we do this, basically what happens. So we get here, and we set it to the left value. So that's 12. And then we look at the right, and it's not null. So then we interpret it again, and then we set it equal to 12, and then we add this one, because the right value is null. So, well, the right is null, but the right node, but the right value is 5. So we add it, and then we go up here, and then we multiply those. So that's why that happens. So how can I need to basically restructure the tree, or how I'm doing this. Because that's obviously not right. Yeah. How can I fix that? Let me get rid of this. And then, just so I don't lose any progress, whatever, I will edit this. So, let's see. Working on, what is it? Different, operators. What's that? Okay, so, how can we do that? So we need to not add it, but we want to add it to the final value. So really we need to build the tree differently, right? So if we have the last one as the initial node of the tree, right? So 5, and then we have another one there, and then we have 12 and 12, then it'd be the right order, you know? Because we do 12 times 12, times 12, and then we add 5. See, and that would be right. So we need to build the tree in like a reverse order, I guess? Is that right? How else could this work? Trying to think, like, what's the... I haven't really done this before, so I don't know. 12, and then this is... Well, no, that's still 12. Then this one's 5. So I want it to be... I want to do this one first. And then add that one last. Maybe we should pass the value as we go along, you know? So we do value plus equals. Do we need to switch on that? Probably. But we'll get to that. So I'll leave that log there. And then we do this. So if we pass the value, when we call it, you know, let's see, this could even be, this could be called, whatever. So let's, pass value. Value. So we, pass as we go along. So we pass 12. And then we have 12 there. But then we still don't multiply it by that. So I don't know if that's going to work even still. But we'll try that. Let's see. When we call interpret, so the search seems to be broken. Interpret. I don't know why it's broken, but okay. 0. And we call it a few times. Let's just build it and see. Shoot. I accidentally left some of this in. Okay. Interpret expert. No, it does not like that. What? Yeah. Oh yeah, so it needs to be in value. There we go. Alright, 438. Right up here. 0. There we go. That was it. Okay, so let's see. That's gonna be different, but I still don't know that it's gonna be right. 12 times 12, that's 5. Okay, it's 348. Yeah, so it's more wrong now. And 20. Yeah, so it's like adding it. If we don't add it, right, and we actually switch like this. This is the best way to use it. Okay, if we do that, and we use the L value instead. Alright, let's see. How did that look? Let x, 12 plus 5. Echo x, 0. Okay, so why is it 0? I use 0. Oh, shoot. Because we multiply it, yeah. So, when we first call it, we don't want to pass 0. We want to pass the, excuse me. I want to pass root right. Root right value. Value dot as dot L value. Is that right? No. Let me think. So, pass 0. I don't know if this is going to work out. Okay. If you just multiply it, then you just want to set it equal to that, or divide. But either of those, it's fine. Let's see. Yeah, really, I don't think that's quite right. Right, it's 12, 5, 0. Yeah, that's not going to work out. Okay. I modified the wrong place anyway. Okay, let's try that anyway. Just set it equal to either of those. Right, okay. 12 plus 5. 328. Yeah. So that doesn't work. Value equals x through L value dot value. Alright, let's see. We're gonna have to think of a different way to do that. Not passing it like this. I'm gonna get rid of this and then change all of the occurrences. Because that is not right. Whoops. I should have abstracted this out, but I did not. X-ray. I don't know why I can't see that. There's clearly some issues here, but okay. Okay, let's see. Alright, so right here. So I need to change this. Too many arguments. What? I thought I got rid of that. I did not say. Okay. That x 12 plus 5. Alright, so it's 204. So it's we're back to where we were. And I know why it's happening. So I need to restructure things. How can I do that? Let's see. Call it with the right. What if we do this? And we just we return that. How would that work? Right. Like we return the value here. Excuse me. That's not good. Okay, 12 plus 5. So it's going to be 144. Yeah, so just did 12 times 12. Uh-huh. I don't want to return value. I want to return x squared r value, dot value. Right, x 12 times 12 plus 5. Oops. 1 plus 12 plus 5. 60. Yes, I did just 12 times 5 now. So, that's not what I want. But I don't want to add it to that one either. Yeah, really I just need to restructure the tree, I think. So, let's see, how are we building the tree? That's in, parse binary expression, yeah. So here we set the L value equal to that. Maybe we should set the right value. Equal to that. Hang on. So I'm trying to think. So if we had a tree like this, right? And we have 12 here, but then 12 here as well, and then breaking off of that, we have the 5, but then like blank over here. You know what I'm saying? Yeah. I think that would work. So we need to set the right value. Basically we just need to do this. Like regardless, we set it equal to that. And then we parse this, and we don't want to set the left, or we don't want to set the right. Right, yeah. So if, like at the lowest point, we don't want to set it. Trying to think about this. So L value equals that. So let's do if there's no more after that. Right, yeah, so we can set the R value here. We can get rid of this. We don't need this check anymore. And we need to iterate this farther, right? I think we need to do 3. I'm not completely sure. Then here we can do if size. Shoot. It's not equal to. Alright, so this actually could be wrong, right? So we need to check this here. Domain size is less than 2. Let's see, if it's less than 2, so it'd be 0 or 1. Okay, it would be 1, right? We want to just return extra. And then use that, right? Yeah. Okay. Otherwise, we want to set this, and then we want to keep going if there is one of those, right? So, parse binary expert, so it doesn't like that now. Oh shoot, because I have these. Yeah, I always forget to get rid of those. Okay, so that compiles. Right, X 1.12 plus 5. It's 144, so that's not working. Right. And then yeah, so it didn't actually like go down. So I need to actually print all the values as we go through. Let's write log. Let's print this one. So L value is going to be extra L value. Right, so we set that. And then we want to print the R value. R value is X per R value. And you can see it. So we should have all the values in it. If we do, then we just need to update the interpretation. I'm going to mess this up somewhere. Why? Oh shoot, because it's an expert, so we need R value dot value right here. Okay, there we go. Stop it. Then let's learn. Look at 12 times 12 plus 5. Whoops. Let y 12 plus 5. Alright, let's look at this. So, L value is 12. L value is negative 5. Why is it negative 5? Oh. Shoot. Why would it be negative? Hey, let me try that again. What? X 12 times 12 plus 5. Yeah, why is it negative? What? That is why. Why would it be negative? We did +5. There's no like money symbol or anything. I don't know. It's because of the way I'm printing it out. Huh. Alright, well we do have it there. So let me try to update the interpreting, right? And then I will figure out why that happens. Because if we can get it working with -5, then we just need to fix the parsing, right? So let's see. So now we're not traversing it far enough. So, yeah, so we're not doing this. Basically, we always want to add the right value. Or, you know, whatever you're doing. Right value. And then we want to do this if it's not null. So let's see. So with this, if we get out here, I need a way to indent better, but I do not have that yet. There we go. So we can do that. And then get rid of this. I'll leave the if statement. And I want to get rid of that. And if it does not equal null, then we want to interpret this farther. But then the left value, it's going to be 5. And then the right value is not going to exist. Right. So, yeah, so it's going to be like garbage data, which is not good. So we need to actually set it equal to, well, we can't really set it equal to something, can we? We need to do something, though, to sort of show that it is like that. Like, that we have not set the R value. So, well, we can just do 0. Because then, even if you put it at 0, it doesn't change. So I think it's fine. Do expr R value equals expr 0. Yeah, so we can just 0 initialize it like that. And then we'll update it here if we keep going. So then it should be 0. So this will just that could do weird stuff if it's multiplied. Yeah, let's do if this isn't right. If expr R value is not equal to 0, then we'll do this. Let's see, that might not be right. I'm not gonna fix the notation. Okay. Let's see. Let's go back. Let x 12 times 12. That's fine. X 144. So it still is not going through the whole thing, you know? Yeah, it doesn't recall recursive. So x for right is equal to null for some reason. But it shouldn't be. So we should be setting it here. So we go here, right? Yeah, then we get an R value. But then we call this again. It's messing up. It's supposed to be 2. Let me try that. So that messed up. What assertion was this? 397. This one. Okay, so the operator got set to the wrong thing. That's not good. We need that. We need to update this to handle that. Let's do case OP9. And then well actually in that case there was an error, right? This means there was nothing to continue after that, right? No. Still didn't work. Oh, because now this one failed. Right. What's that about? We said it too many times now. Huh. Right. Yeah, because of this. So this does need to be plus 3. So let me think about that. So we have 0, which is the first value, then 1, which is the operator, then 2, which is the next value. Right. So that's 3. And then we have a 4th and a 5th, which is the next operator. Right, okay, I see. So we need to actually set the operator in here, though. We don't want to skip over that operator. So we need to do this. Right. So why is it not setting expert right? Oh shoot, because we need to no, because we do turn expert here. We do something here. Less than 2. I don't know if this is being called. That's fine. Let's just look. We do have less than 2. We do not. So this isn't being called. We need to do less than 3 because we have the operator right. Less than 2, so it calls that. Hmm. So it failed. The assertion failed. I think we don't have the operator. Hmm. 144, yeah. So it says it too many times. Maybe I should print all the tokens that we have. We don't want to set this to none. Well, here's like the tree. So we have the left value, which is 12, and the right value, which is 12. Yeah, but then we don't want. Yeah, we need to play this again. Learn the game. Okay. So it's gonna play this up. We have this. So this is more like what we want. It's not supposed to be -5. I don't know why it is. We have the left value, which is 12. The right value is 12. And then we go down one more. Left value is -5. It should be 5. And the right value is going to be nothing. But for some reason the operator is not right. Right, wrong. You print. You are expert operator. No, command 1. And then I can see what it is. 1. We can print it out. Plus 5. Let's see, command 1 is 5. Okay, so that's why it doesn't work. Why is it 5? So then 0 is the operator. So if I okay. Yeah, we can't do that. We need to handle this differently. Right. I forgot to consider that. So that's why it's all wrong. So so how can I do that? We need to call it again. Can't do that. So we basically when we call it again, we need this to be 1. And this one needs 0. Because operator is going to be at the 0th position in that case. So what we need to do we need to ignore this value, right? Because when we set it to 1, and then 2 is the next one. So it equals that. Zero, return, no. Okay. So basically I want to ignore that one, but let's see how that looks basically. Let's get rid of this one. And we'll just it'll be set to null, and then we'll be able to ignore it. Oh, that's fine. Yes, 2 large. We have left value is 12, right value is 12. Value is 12, right value is 5. Why is the left value then 5? Why does it oh shoot, it calls it too many times. What? Okay. So we're gonna need to handle this different. I know exactly what we can do basically. So we set the expert operator equals operator main one. Well it's gonna be 0 in this case, right? So I'm gonna change that, right? And make it 0. So that's the operator. The left value we don't set here. So I'm gonna keep that for a second. And then we set the right value equal to the first one. And then we call this again. First, so that's the right. Then we set square root right left equals square root of u28 command 3.5. So if that exists, right? But we can't set it like that exactly. We set it here. Right? Yeah, equals expert of u28 command 3.5. It's command 2 is gonna be that. So basically means if size we do this. Okay. We call this again. We set the we don't want to set the left value. Set the operator. Okay, and then here we need to actually set. We need to set this. So when we call it, we need left value equals expert of command 2.value. That's value. Hang on, how do I set that? Expert right to left. That's not what I want, but S for L value. The L value. This is in the set bar though, so it's not quite right. But X for L value equals that, and we need to set that in left as well. Okay, let's see. Does it compile? It does not. Yeah, we don't have expert. We should have expert. Oh shoot, because I need this. This is the wrong place to put it actually. Let's put it in here. There we go. So we have that. for L value. 296 right here. U2. Sorry about that fun. Yo. Let me comprise. It's fine. Thanks. 720. And it's still not. Yeah, we have garbage data now. It's not good. Okay, yeah, I think I broke stuff. Made it worse. Right. So let me think about how else I could put this. Right, so this is assuming we start on the offer. So I think we are not, though. I think I need to change this with plus. I think it goes too far. So that. Right. Let's see. Let's get rid of this. I don't think that's gonna be right. Let me set it in here. So we're gonna start on a vacuum like that. 5 plus 5. So we're gonna start here. Then we need to offset it, so we start here. We want that to be the right value. So I don't know how this is gonna work exactly. So because we don't want, like, if we set the right value to be this, like this expression, then it evaluates that first, and we don't want that. So the right value to be this, and the left value to be this next expression that we have here, right? Like if we have more. So it could just be a single one. So I don't know. Expert, U2, then one not value. This will be 3 and 3. Command 1 and command 0 actually. Well, 12 plus 5. Why did it say 12? Because of this. Okay, let's see. I think it's 12 plus 5. No, it's still 7. Oh shoot, because this already doesn't exist, does it? It's 2. There we go. Missing 3. 4. Yeah, because now we have 12 and 12, but then we have 12 and 5. And I don't know where this comes from. Why do we call it again? Okay. So. I don't know. Alright, let's not do that. And what we're gonna do is we need to build it backwards, really. So we need to start from the end. How can I do that? Oh, Alright, we're going to set the R value equal to that. We're going to call this again. We just want to ignore the secondary L value. How do we do that? Yeah, because we have value 12, R value. Shoot, I got rid of all of the logs. We have left value is 12, right value is 12. I don't know why. I don't want that secondary one, so I need to fix that. If why is it 5? I don't want the secondary one there. It's fine. I think that just got garbage data. Or something. Wait. 522. Huh. Okay, that doesn't quite work. No, we have an extra one. We don't want that. Can't do that. Just want to set the R value. I don't know. It's probably very obvious. Oh, 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 oh. Okay. Well, maybe it's more like that. Yeah, there we go. So we have the start, and the start one is not any value because it's an expression, right? So we have the left, which would be 12, and then the right, 1 to 12 as well. And we want the left of that to be 5. And we want to just ignore these values because they're like non-values, right? Hello, how are you doing? How are you? Okay, how can we set it to that? But then we need the operators as well. It's like, come on, here, so that'd be plus. This one is times. That, basically. Well, plus, yeah, like that. And these are basically don't mean anything. Uh-huh. So we need to look like that, basically. But how do we... we could set the right operator. Yeah, let's see. Actually, what did we say? Operator. Oh, we don't have it. We can set it here. Or, you implement doubly linked list. Yeah, I was doing that last stream. Just to kind of mess around, you know? Not actually for using it. Equals command 3. What's command 3? How do I set that? Yeah, operator. Yeah. Yeah, operator. Operator. There you go. Oh, shoot. Dang. I forgot to change the stream title. No, that's not what I'm doing right now. My bad. Today I am working on text editing. Let's see. That is what I'm doing. I forgot to update the stream title from last stream. Yeah, sorry. That's not what I'm working on. Nobody else said anything about the title. So, yeah, that is a thing. That's my bad. Yeah, I forgot to change it. So that's not what I'm doing today. That was last stream. Okay. So that'll skip over the operator. And we don't want to set that here. So then if, it's less than 1, less than 2, and then x. Okay. Then we have null. Right. So that should be okay. Then we'll set the operator. If it is, except the next one as well. Yes. So what do we have there? I think I need to output this. We never set the right value, do I? We need that actually. Okay. Let me skip over that. Yes. Oh. Alright, let me write log. Our value is this. Our value. And then up here, log L value is x per L value. Oh, I messed it up. Why? Oh yeah, it's dot value. Made that mistake before. Not very long ago. Okay. Well, that's fine. It's -5. Why is it negative? Get that. Okay, but that works. But why is it segfault then? Turns expert. Shoot, but this doesn't exist, does it? So when it tries to call that, it cannot. So you can do if command size is greater than 3. Then we want to do all this stuff. That's fine. Huh. It's gonna be less than 3. Oh, shoot. Yeah, no, that's right. Okay, it's 12. Times 12, that's fine. That's not it. Less than 2. Hang on. So, equal to 2. And 0. Okay, let me think about how this works. So we have tokens that are 5 plus 5 plus 5. Right, well, let's do it where I see it. 12 times 12 plus 5. So we have this one. That's where we start. And then we grab these. So this is the 0th one. This is 1, the first one. This is the second one. Okay, second token. This is the third token. So we skip over these. So we do this one plus 3. So there. So it should start at this. We set the operator after to this one. So that should be right. So the command size would be equal to 1, right? Because 1, 2, 3, 4, 5, 2. Actually, do we need to do plus 4 here? No, that was too many. Well, no, because that's right. Shoot, but it's grabbing the right value, which is not right. So we need expert. We use calc, right? So it would, set everything else to 0. 720, that's not right. So, shoot, it's 144. We did 144 times 5. That's not good. So it must be 5 is what it's setting the operator to. That's almost right, though. So then we did 12 times 12, right? And that's what we want. But then we need to add 5, not multiply 5. I think I know why that happened. So we're looking at the wrong operator when we try to do that. Let me index this properly. Okay, this one too. There we go. So we do that and get the R value, but then the left value equals that, and we return that value. So we need to look at the expr right operator, right? I think so. I think that's what the issue is. Okay, 12 times 12 plus 5. 149. That's right. Y 12 times 12. So that should be 144. Let Z 5 times 5 minus 5 plus 10. That should be 30, I think. 30. There we go. Okay, so that seems to actually work properly. So I'm giving it these. So yeah, now we sort of construct the tree a bit differently. So now it looks more like this. We have the main one, which really is the operator. That's what we can see that as. We have that. Then we have the value. So let's actually do single digits because that'll be easy to see. So 5 times 5, and that's the right value. But then this one actually breaks off. So this one actually, maybe that's not a good way to look at it. We need more a secondary one like that. Then we have here we have another one. So we have the next operator and then the value. So say let's do minus, right? Minus 5. And then we have another one which breaks off here, which is just well, actually it's going to be a thing. So what is it? What? It's not going to be any of them, is it? Then we have 10, right? So plus 10, like that. So we sort of break down into here. So we go here. Well, actually start here. So we do 5 times 5. We do that, so it becomes 25, right? Then minus, so we subtract 5, so that becomes 20, and then we add 10, it becomes 30. So that is sort of how it's built now. So I can commit this, and then I'm probably gonna have to end the stream in about 2 hours. I think it is a good time to end it. So let's do implement the rest of the operators. Yeah, so now they should be working. We need some more tests, and also there's not like precedence, orders of operation, whatever. But it does work, so we can reload this. And it seems to have actually worked. So yeah, that is going to be the end of the stream. So thank you for watching, and I'll see you guys next time. Bye.